Hi madam, I am Ricky Tuan from Group 1415 as the group leader for Group 5, which we get a topic scheduling algorithm. I responsible for this video recording session. So let's start the problem solving. So our question is use the preemptive priority method and the round robin method. So for the first question, the preemptive priority, we know that the preemptive priority means that the process need to be choose depends on the priority, and the process can be stopped when there is a new process coming. So we check here. The first arrived process is P1 as the arrival time is 0 millisecond. So we put a P1 inside the ready queue, and after that we execute it. Then when execute, we need to check for the arrival time. Next, the arrival time is 3, so that the P1 can only execute until 3 milliseconds, and it need to stop first to let the P3 coming in into the ready queue and compare among the priority. Compare among the priority, then when we compare, we found that P3 has higher priority than the P1, so we need to execute P3 first. Then we also, when we execute P3, we need to check for the next arrival time, which is 5 milliseconds for process 5. Then we put in the P5 inside here and updated the remaining time for P3, and here it stopped at the 5 millisecond. So now as it is stopped already, we need to bring in the new process, which is P5. The P5 coming in, then we compare among the priority. The P5 have highest priority, so we just let the P5 come in first, and also we do the same thing, check for the arrival time, which is 7 P2. So P2 coming in here, then we compare again. Also we need to update the burst time from time to time. Every day each time we put in the new process, we need to when the process is stopped, we need to update the burst time. So now P2 is bringing in, we also need to compare the priority. Still the P5. P5 after updated, the remaining burst time is only 3 milliseconds. So now execute P5 again. Until 8 milliseconds, it need to stop because a new process is coming again. P6. So we put the P6 here, and also we just continue to compare the priority and put the process in the Gantt chart. So now it's P5. We execute until 10 because when we check the arrival time, next process, which is P4, the last process, is coming in at 10 milliseconds. So we just stop at 10 milliseconds, and also the P5 is done already. So the behind here, we just need to compare among the priority. The highest priority will be execute first. So P5 completed, so now it's P2 here, and P6 here, and P3 here, and P1 here, and also P4. This is followed by the priority. So for the waiting time, we just use the time it come into be processed. We put it in Gantt chart, the start, and we minus with the arrival time in the table. Then we can get the waiting time. But for the special case like P3, it has been separated into 2 sessions because here it has been stopped by other process, and after the other process with higher priority is completed, executed, then it can be executed. So here we calculation by using use the second session, the starting time, we minus with the first session, the ending time, then we get the waiting time. We just plus with the formula the coming time minus arrival time, then we can get the average time. Then for the average waiting time, we just add all the waiting time, then we divide with how many process we got, then we get it. So for the second method is round robin, we use quantum time equals to 3 milliseconds, means that the our process, each of the process can be executed only for 3 milliseconds, and it need to stop and change the process being executed. So for now, like this, we just using the same concept like first come first serve. The P1 is coming first, so we just put a P1 inside here, P1 inside here, and for 3 milliseconds only. Then we need to update the burst time, and we need to check among these 3 milliseconds what process is coming in. So followed by here the process coming in at 3rd millisecond is P3. So P3 is coming in. We write P3 into here. Then we need to bring down the P1. So when we bring down the P1, we use the updated burst time. Now it's P3 turn, so we just put the P3 inside the Gantt chart. P3 is inside the Gantt chart and also execute for 3 milliseconds only. So okay, here the P3 stop, and we need to check which process coming in, which is the P5 coming in 5 milliseconds. So P5 coming here already, so we just put the P5 here and we bring down the P3. We bring down the P3 here. Okay, so now again it's P1 turn. So we just executing the P1 6 until 9 milliseconds. So now which process coming in? P2 and P6. So here we need to know P2 and P6 is coming in. So we need to put it inside here. Then after we execute the P1, we need to update the remaining time and bring it down again at here. So like this lah. When you bring down here is the P1 newest location for sequence for the execution. So after that we need to execute the P5. P5 is around 9 milliseconds to 12 milliseconds. So around this time P4 is arrived. So we know that P4 arrived, so we need to when we execute the P5, so here P5 we update the remaining time, we bring it down. We bring it down here P5. But before we bring it down, we need to insert the P4 before it. Because before this our newest is P1, right? So we need to bring in the P4 here and we bring down the P5 at here. So after that all the process is coming in already, so there is no more confusing thing. We just need to bring in the process here. After P5 executed is P3. Then we just bring one by one. Also no need to use all of 3 milliseconds. If for example like this, P2 only remaining 2 milliseconds already, so it can just executing for 2 remaining seconds, and the P2 is completed. So cannot no need to deal with it anymore. Just continue with the new process here. So after this all is the same method lah. Just execute each process for 3 milliseconds, 3 milliseconds, 3 milliseconds, and bring it down, and bring it down like that. Waiting time is a little bit confusing lah, but never mind. It's also the same. We just using like this. For example, we calculation for P1, we also use the which time is coming in into this into the Gantt chart. We put it in the Gantt chart and we minus with arrival time. This is the first in the first bracket. At the behind here, we calculation by the same method. We calculation the differences between these two. Process time here. 6 millisecond we minus with 3 millisecond, and here 20 millisecond we minus with 9 millisecond. Like this we can calculate all the waiting time and also the average waiting time. Okay, so now for the second question. Second question, also we use the preemptive priority and the round robin. So it is basically the same thing lah. We need to compare the priority. We need to check about the arrival time, which process come here first. For example, here P1 coming first, then P1 in the ready queue first. Then we uh, check for the priority. But now check for the next arrival time is first second, 1 millisecond is already coming. So P3 is coming in, so we put a P3 inside. Then we stop it. We check, compare the priority. P1 has longer priority, highest priority lah. So execute the P1 first. So for this question, there is no a process which is been separated lah, because P1 execute, then P3, then P6, P4, P2, P5 and P7. So like this. Or for the waiting time calculation, so it's not confusing like just now. Yeah, so for all this, just uh, one one time we can calculate it lah. And also for the average waiting time is using the same method. So for here the round robin is 5 quantum time is 5 millisecond, which each process can execute for 5 millisecond. So we also see P1 is coming here first, so we put in the P1 and execute for 3 millisecond. But our quantum time is fine, so it no need to fully utilize the 5 millisecond. It can stop when it is complete. And also the next coming in is P3, which is coming in at 3 millisecond, so we execute it. Then the next is P2, then followed by P4. Here is the question. P1 coming here first, then P3, then P2, then P4. After that is P6, P5 and P7. So just the same thing. If P6, P5 and P7. Oh yeah, sorry, here. P6, P5 and P7. But here, when we have arrow, means that the process cannot be done in the quantum time. So we have the arrow to bring it down. So for this didn't have arrow because it done the process is fully executed completely at the within the quantum time. So for the waiting time calculation is same as just now lah. So that's all for me. Thank you.